Ladies and gentlemen, welcome back. We are focusing on more trig equations today. Alright, if you didn't quite grasp the last video, I would strongly encourage you to maybe go back, read over your notes, or maybe even rewatch part of the last video, because honestly guys, this video, it works right off of what we were already doing, okay? So again, we're still going to need to simplify the trig equation. We're still going to have to draw a unit circle. We're still going to have to write out our general equations, and then it changes a little bit. Alright, so this all works off of the last video quite a bit. So, when we look here, solve the following equation in the interval 0 to 2 pi. So we know what this means. We know that we're going to make a list. Here's what's different. This is what's different, guys. Our angle. Our angle is different. What I'm going to do, I'm going to actually skip to our hint here, right down here at the bottom. We must get the trig function alone. We cannot alter the trig angle. Alright? So this is important for you to understand. I am not doing anything with this 2 theta, and I know we talked about this in class. Where is the 2 theta? The 2 theta is inside of the sine function. If something is inside of a sine function, well, you can't do anything with it until you get rid of the sine function. Alright? So again, if you see something like this, you're done simplifying because there's nothing left to do to get the trig function. Oh, that was a bad bracket. Holy cow. Yikes, I'm going to redo. Trig function is alone. Alright, there's nothing left to do to get that trig function alone. Alright, so we're ready to just draw our picture, our unit circle, excuse me. And I do something like that. Yikes, okay, I've done better. And we think here, well, where is my sine, or my y value, positive 1/2? Well, that's in two places. That's either here at pi over 6, or it could also be where? Over here at 5 pi over 6, which is great. I now have my unit circle. I now can write out my general equation, or equations, I think, in this case, right? So now here's the big difference. My angle is no longer theta, right? The angle that I have inside the sine function is 2 theta, so I need to write that when I write out my equations. So 2 theta equals, let's see here, we got pi over 6 plus or minus all the way around 2 pi n. I also have 2 theta equals 5 pi over 6 plus or minus 2 pi n. So here's what makes this different. We're not done yet with our general equation, or general solutions, I should say. I need to get rid of these 2's. So let's see here. I know that if I want to get rid of a 2 here, well, that means I can either divide by 2 everywhere, or I can multiply by 1/2. So I think it's going to be easy on this piece to divide by 2, but here I'm going to actually end up multiplying by 1/2. And I hope that makes sense. Divide by 2, multiply by 1/2, divide by 2. It's all the same thing, right? 2's are in the denominator everywhere, and that's what I care about. So now, let's see here. This top equation, it's going to be theta, and then, well, 1 times 1 is 1, 2 times 6 is 12. So I have pi over 12 plus or minus pi n, and then I also have theta is equal to 5 pi over 12 plus or minus pi n. Alright, so do we see the difference here? My angle that was inside the sine function was 2 theta, and so when I divide by 2, every part of my general solution actually goes down, or it gets a little bit smaller, which means I'm probably going to get more angles. And let's see how that works now. So I go ahead and remember that if I'm making a list on an interval between 0 and 2 pi, I got to start finding solutions here. I got to start. So I know that my first one is going to be pi over 12. And then let's also think about this real quick. If I'm going to be adding pi, well, I can also write that as 12 over 12, right? 12 pi over 12. And I think that will be helpful because now, should I go ahead and add 12 pi over 12 here, or should I take my next solution, my next equation, I should say? And I think, let's see here, so 1 pi plus 12 pi is 13. Nope, I want this 5 pi over 12 to be next because I want to go in order. So 5 pi over 12. Then I would come back, I would add my rule, or add my step. So pi over 12 plus 12 pi over 12 is 13 pi over 12. And 5 pi over 12 plus 12 pi over 12 is 17 pi over 12. Could we keep going? Well, I'd have to add 12 pi over 12 to 13 pi over 12, which is 25 pi over 12. 25 divided by 12, nope, that's bigger than 2 pi, okay? So this is my list of solutions, okay? All right, let's try another. I take a look. I see I have sine 3 theta minus 1. All right, so I can rewrite this as sine 3 theta equals 1. This is great. So I can sketch a unit circle. Again, doesn't have to be perfect, like mine. That was a joke. Where is my y value? I should gotta write this. Where's my y value? 1. Well, there's only one spot, guys. There's only one place, and it's straight up at pi over 2. So the only real difference between the last video and today is that I'm not saying theta is pi over 2 plus or, like, what is it? It's going to be pi over 2 plus or minus 2 pi n. It's not theta, it's 3 theta. Alright, 3 theta is equal to pi over 2 plus or minus 2 pi n. Which then means I need to divide everything by 3 or multiply by 1/3, right? So I'm going to sneak a 1/3 in there. Now hopefully that makes sense then, that this should be theta equals pi over 6 plus or minus 2 pi over 3 n. Alright, so I have my general, but if it's giving me an interval, so I know I need to make a list. So we do it, right? It's as easy as that. I know I'm going to start at pi over 6, and now it says that I need to add 2 pi over 3. One thing that we can always do, again, is get common denominators, right? Like, so instead of saying 2/3, I think I'm going to consider this 4/6, just for helping me out with adding. Which means then if I'm going to take pi over 6 and add 4 pi over 6, I should have 5 pi over 6. And if I add another 4 pi over 6, I get 9 pi over 6. If I add another, I get 13 pi over 6. Oh, wait a minute. 2 pi is the same as 12 pi over 6. Okay, so this one's no good, and this I need to reduce. So all I'm going to do is I'm just going to make a new list, clean everything up. Pi over 6, 5 pi over 6, and then 9 pi over 6 reduces to 3 pi over 2. Alright? Now, you don't have to do this in 2 steps. If you can do all of this in your head, go for it. I don't care. But I do care that you get to here eventually. Alright? Okay, let's move to the next page. We've got 3 more problems to do, and we will call it a video. Let's see if I can... There we go. Nope, nope. Sorry about this, guys. Okay, so number 3. First it says to solve. Ooh, it says general. That's good. So we just need solutions. General solutions. So the equations. We do not need to make a list, which is always nice. First thing I'm going to do is probably get rid of this 2, right? And by get rid of, I mean divide by. Okay, so root 2 over 2. Please, 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 please remember, I know there's no parentheses. Where is the 3x? The 3x is inside the cosine function. So we cannot divide by 3. We are good. We're ready to draw our unit circle. We're ready to draw our unit circle. So we draw it, and I ask you, where is the cosine ratio root 2 over 2? Well, that's when x is root 2 over 2, and that is at pi over 4. And where else is x root 2 over 2? Oh, down here at 7 pi over 4. Okay? I hope that makes sense. Again, if we were writing, I think we're going to need 2, because we have a pi over 4, and yeah, there's not a single pattern that'll get us to 7 pi over 4. So I'm going to need to say pi over 4 plus or minus 2 pi n. I'm also going to need to say 7 pi over 4 plus or minus 2 pi n. Now remember, I left the left side blank to make a point. What's going on the left side of both of these equations? 3x. 3x, because that was the angle inside the cosine function. So yes, we now need to divide by 3 or multiply by 1/3, whatever's easiest. Alright, so 3's need to be in the denominator everywhere. And let's see here. Okay, so we get x equals, well, this is just pi over 12. And this is just 2 pi over 3n. So we do the same thing. X equals 7 pi over 12 plus or minus 2 pi over 3n. And guys, we are done. Alright, maybe put a comma between them just so I know what's going on. Box them, whatever you got to do. But we are done. And again, that's because we just wanted the general solution. Alright, number 4, back to a list, right? We're giving you an interval, so we want a list. Let's think about this one. Oh, this one's not too bad. Please remember, though, that we want the trig function to be alone, and right now it's being squared. Kind of like if you had x squared is equal to 25. We don't want that. We want x is equal to plus or minus 5. So same thing here. We got to square root both sides. So I get tangent of 5 theta over 4. Now be really careful here. When you square root 1, you actually get plus or minus 1. And that's pretty nice because we should remember, these are some of our favorite places on the unit circle. I guess I should speak for myself. When is tangent plus or minus 1? Well, that's when my x and y coordinates are the same, right? So that would be up here at pi over 4, because it's root 2 over 2, root 2 over 2. Or over here at 3 pi over 4. Or down here at 5 pi over 4. Or lastly, 7 pi over 4. Alright, those are our solutions. Okay, so we know what's coming next. We write our general equation first, or general solution, excuse me. How many equations do we need here? I hope you said 1. 5 theta over 4, which was our angle, is going to equal pi over 4 plus or minus, and then we have a nice rule or a nice pattern for every single step. 2 pi over 4, 2 pi over 4, 2 pi over 4. So the only thing I'll say is instead of writing 2 pi over 4, I'm going to write it as pi over 2. Alright? This is awesome. This is good. So now we need to solve for theta, right? We don't want 5 theta over 4, we want theta. So the easiest route here would be to multiply by the reciprocal everywhere. Which is great, because cancel, 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 reduce. I'm going to change this to red just so we can see that this is reducing to a 2 and a 1. Alright, I know that's a little messy, but it's cleaning it up a lot, right? So I have theta is equal to pi over 5, right? The 4 is canceled, plus or minus 2 pi over 5n. And that's awesome. That's great. So now we're ready to make our list. We know that we're starting at pi over 5. And we know that we're adding 2 pi over 5 as many times as possible before we get to 2 pi or past 2 pi. So 3 pi over 5, 5 pi over 5, 7 pi over 5, 9 pi over 5, 11 pi over, oh shoot, wait a minute. 11 pi over 5, that's too much, okay, right? Because 10 pi over 5 is the same as 2 pi, so we know that that's no good. We also know that we can do something with that. And so I finish up by making a nice final list. Pi over 5, 3 pi over 5, pi, 7 pi over 5, and 9 pi over 5. And we call it a day on that problem. Oh my gosh, I'm actually kind of doing okay on time here. Let's do one more. Actually, hold on. Let me make sure everyone got that. Sorry. All right, and now we're doing one more. Let's take a look at this last one. Oh, good. General. I like that. So we're just getting equations, and then we're calling it a day. Again, what's the goal? Get the trig function alone. Get the trig function alone. First thing I would do is probably move over that root 3. So I got negative root 3. And then my next step would be to divide by 2. Please remember, when you divide this by 2, the angle is not affected. Okay, again, you cannot do anything with the angle because it's inside this function. You can't touch it. So when I divide by 2, I get cosine of 2 theta equals negative root 3 over 2. And now we can start the same thing that we've been doing for the last couple of days, okay? So I draw a unit circle. Oh gosh. Oh my gosh, that's terrible. All right. Draw my unit circle. I need to find where my cosine would be negative root 3 over 2. And that would be at, right here at 5 pi over 6. Or 7 pi over 6, right? Because I need my x value to be negative root 3 over 2. So those are the two places. And now I can start. I can say 2 theta equals 5 pi over 6. And then please remember, there's not a single rule to get me from solution to solution back to the starting solution. All right, so I need to go two different equations. So 2 pi n on one, and 2 pi n on the other. When I take a look at this, I need to divide by 2. I'm going to multiply this one by 1/2. I know I'm sliding it in there, sorry. 2, 1/2, 2. I hope everyone's okay with what I'm doing there. If not, please ask. But yeah, now that I have that, I am good to write some general equations. So I have theta equals 5 pi over 12 plus or minus pi n. I also have theta equals 7 pi over 12 plus or minus pi n. And because I asked for the general, you are done. And we are done. So, I hope you're doing okay on this. I hope that you're figuring out how to solve these trig equations. Again, it's just one little extra step compared to what we were doing in the last video. Alright, so please make sure to watch. Well, you already, I'm messing up now. Please make sure to jot down any questions you have so that we can talk about them in class. Of course, we will practice this the next time I see you. Have a good one.